IOTA is a DLT, is a distributed ledger technology. Some of the advantages it has is like immutable data transfer. It means that whatever data you're storing, it's impossible to actually change the data that is being stored within the IOTA blockchain. So one thing I've used to kind of try and store this data within the IOTA blockchain is something known as MAM channels. It's a way of storing the data in the blockchain. Number one, the first thing is that the message is encrypted, which is masked. And then the message is confirmed to be coming from a device, meaning it's authenticated. And then a continuous message stream is created in a tangle that will carry on until the device stops publishing data. So that means that if you have a device, it could be a laptop, it could be an IoT device, you could endlessly just publish data into the IOTA stream until it form a stream of data. Depending on the position of where the data is, because it actually forms sort of a graph. Depending on the position where you are, you can actually access a certain amount of data or the whole of it. And yeah, to do all these things, you need something known as a root ID and keys. And keys also helps in encrypting and decrypting the data, because you may store data in the blockchain, but you don't want many people to see it. So you may use something like a root and key to kind of encrypt that data. Now, how do these two come in together? So as I said, like when you store something on IPFS, you get a hash that says it's this file. This file has a certain hash. And then that hash, ideally you could store it in an immutable database, being the blockchain. And in this case, you're using IOTA. But you could use other blockchains. You could probably use Ethereum. You could probably hash a document and put the hash on Ethereum, or EOS, or be in the Binance Smart Chain, or in a smart contract. When you put it in that blockchain, it acts like a source of truth. What it means that if I come in again and tamper with that data, someone can easily go to the blockchain and then reference and see, okay, the hash that this guy is giving me is not matching with the hash that is already on the blockchain. That you can know that this document isn't legit or has been modified. And actually, that's what the demo aims to prove. So the way I've structured this project is quite simple. It may seem complex. So under utils folder, we have 3 files. You can call them classes. So one file is dedicated to just reading a file from the local machine. Another file is just dedicated to handling anything that's dealing with IPFS. In this case, it's uploading. That's the IPFS helper. And then the third file is called the mamhelper.ts. That is just dedicated for uploading content to the blockchain. It all runs from the main file, which is the index.ts. And the first thing we do, we have a sample file here, which is called sample. Over here in sample, you have a file called sample.txt. And the first thing we're trying to do is to fetch that file and convert it into a buffer so that we just have it in code. And for that, we're calling the file helper function, which is one of the utility functions that I've put in there, just to deal with that. And we're calling the fetch file function. And if you go there, you can see this is just the file, and it's just dedicated to fetching a file known as sample.txt. That's all it does. For the second bit, if you have a file, the next step you want to do is you want to try and upload the file to IPFS. Hence, we have this bit here. You're saying if there's a file, we call on this helper function, and then we actually call the helper function .add file function. And if you go to the IPFS helper.ts, you can see there's a add file function. where it, first of all, it connects to a node, and then in this step, it actually goes in and uploads the file, because you can see over here it's node.add file, then it's true. After that, we display the CID of the file, the unique identifier, the hash that you get when you upload a file to IPFS. And then we actually log the path in which can be able to fetch the file. So this is one of the providers of this IPFS. So it's like Cloudflare is running a node on IPFS. And from that, you just have the basic HTTPS cloudflare.com, ipfs.com/IPFS. And then at the end bit, you add the CID or the hash. When you add the hash there, on the URL, it will automatically just try and fetch the file. And that's what this file does. And the last bit is pretty much easy. So if you have the hash of the file, which is, again, the location of the file, what we do is we try and get the date, what's the current date at the moment. So we have these functions here, and then we try and create an object where we are going to store all this information. And the information we are going to store is, number one, the name of the file. The second thing is the date and time, the current time, and then you're going to store the hash. And yeah, by storing the hash on the blockchain, once it's in the blockchain, it's immutable, and anyone can check the hash to see if it matches what someone else's house. And then once you do that, we call on this function, which is the mumhelper.create function, which is again the third helper file. Yeah, what it attempts to do is to try and connect to, again, a blockchain node, and then try and post this information from it. So over here, you can see it has connected to a couple of IPFS nodes. You can see the reference, you can see the IP address, and you can see the identifier. You can see the version. You can now see the hash that is generated, the CID, which is over here. And now it's saying your file can be found here, which is the path where you can see the file. And we have a couple of things related to the blockchain, like the seed, address, root, next root. And then over here, it shows that now the hash has actually been posted to the blockchain and it's available here. So what I'm going to do right now is I'm going to try and open this link. We see it in the blockchain, the hash and the timestamp. And then you're also going to try and open this link to see the file that is stored. Yeah, so upon clicking on it, it takes me to this site. It's sort of a block explorer. And over here, the message.json, you can see the file name is sample.json. You can see the date today. It's 10th. It's 23rd. You can see the time it posted was at around 4:58, and you can see the actual hash, which is this. You can go back and try and open the file itself. So when I click on this Cloudflare link, it opens up on the browser, Cloudflare, ipfs.com, like that. Then you see Hello World, GD. And if you actually go to the actual file, which is sample.txt, you can see it's Hello World DD. Now what I'm going to try and attempt is I'm going to try and add more text and see if the hash changes. And all that data will be posted on the blockchain. So I've said Hello World FileCoin orbit. So I'm just going to stop this application again, and I'm going to run it again and give it some time. So you can see the hash ends with VSJZ. That's the first hash. Over here, the hash has changed. It's another different hash, because here it ends with NJ8B. And what else? You can see the file is posted, and you can see it, the link here. So I'm just going back to the same link that I opened. Yeah, so on the same link, it's 502. So you can see at 501, this file was posted again, and it has this unique hash, which ends with NJ8B. And previously, the hash ended with SJZS. So it shows that these two files are actually different. When you change a document and then upload it on IPFS, it gets a different hash. Then I'm going to do one more demo. This time I won't change the document itself. So the document just remains as hello world FileCoin orbit. And I'm going to try and upload it again. And I'm going to see if the hash changes. So again, the hash is still the same because you can see it ends with WNJ8B, WNJ8B. You can see it's already posted on the blockchain, and you can actually check. Now it's 503. Yeah, and you can see at 503, this data has been posted, and the hash is still the same. I'll speak about use cases, and then I think after that I'm done. Yeah, so for the use cases, the ones we have especially, we want to prevent forgery cases, especially in these sensitive government documents. Like you have like certificate of export, certificate of origin. And the same logic applies. When you hash these documents, it gives you a unique hash. That unique hash we normally store. We store it on the IPFS. I mean, the hash is stored on the IOTA blockchain, and we can come back and check if let's say an incoming document is coming and you want to check the validity of it, the hashes need to match. And then the other unique advantage is that you can see the history of a document. From that, you could see like from the first demo I ran, where I posted the first file, and then I went to the second file where I modified it, then to the third file where I just left it like that, I didn't modify. You can actually see the trail of events that has happened to a document. And the same thing happens in like government agencies, because you may have like a document that has been rejected, and again it needs a review. So that document again, yeah, will go uploaded on the IPFS. The hash will be on the blockchain. When it gets reviewed, the hash will change, and then you just reflect that on the blockchain. Again, access control can be implemented to restrict access to people who can access a different document. So that's a bit advanced. You could, that information that is shown over here, you could actually obfuscate it using like a seed or a key. But that's like an advanced topic. But it's possible to have that information hidden or have it limited to a specific number of people. And then, yeah, there are possibly some kind of limitations with FileCoin, with IPFS, and some of these other solutions like FileCoin could actually come in and solve these problems.